on this computer. All right, so I decided, I don't know if you saw or not, I added MATLAB. So I know that if I leave it to you, you're not going to do it. So if you're going to do it now. So it's the same lecture I put for MATLAB. You started it and it stopped, right? So what I'm going to do is we're going to go over the slides. Well, I'm going to go over the stuff from my iPad. You have it with you. But I want you to do it in MATLAB Online. Just type everything once. You have the solutions, like is in the lecture, but I don't want you to look at it. So just getting used to typing the command without needing to look back at the lecture. All right. So how many of you have iPad, a computer, something you can type in? Raise your hand. Okay, most of you. If you don't, and there's someone that raised their hand, you can move and sit next to them. It's okay if you work together. All right. It's gonna be in your homework too, so you need to be able to do it. All right. Most of you probably know how to do it. It will be boring, maybe, but it's a good reminder. So we went through this part last week, right? So this was just basically how to write polynomial and blah, blah, blah. The main thing that I forgot to talk about it here was how I like the codes to be formatted. So every time you submit an assignment or something here, what is the goal, like subject of the assignment, and then you can write your name as a comment, right? For example, my name, then I will probably date it, and then homework 2, question 1. So make sure that that's there, even though you submit, it's a good habit to write your name and date and version of what you're doing in your MATLAB code. If you have, you should usually do it. If it's not your habit, do it. And then I like you to create sections for things. And how to do section? You can use this double % sign, and it creates a section. So the good thing is when you're running, you can run section by section. So for example, if I am giving some input, like just populating vectors, just some variable, like some fixed number, some constant, you can create a section for that. So when you run that section, it just gives your values, A, B, C, D, your variables, some values, if you have them, or give them 0 if you need to figure them out. So this way, MATLAB would run the code for you faster. And for someone that's checking, they can see what variables you have, which one of them going to be your input that are going to change every time that you're running your code. All right. So usually that will be your first section. You can just give it a name that is obvious. And then you're going to put your code. If you have it, usually you don't want to print everything, right? So make sure that you put the semicolon. If it had to be printed, you can have a section printing the result, right? And then call your variable and print. Don't just print like that. You're gonna probably say printing results, right? And then you want to write that A equal to something. So when it's printed, it's not ans equals something and the next ans equals something, ans for answer. It's A equal to the value, B equal to the value. So for someone looking at your result, printed result, it's very easy to interpret what is it that I'm looking at, okay? So don't forget to do that. Make sure that is a good habit that you're developing through these. When we are grading, we look at these as well, this editing part. I'm gonna make sure that I allocate a little bit of point to it. So if you're not following the format, you lose point, just so everybody gets the habit, all right? Let's say that's all of my code. I wrote that, and then let's say this is what I wanted to print. You save your file. Now here is the thing. I want you to publish your results. If you had robotic with me, you know that that was the only way that you could actually submit. So to publish, you go to publish, and then here, you can publish as PDF or as HTML. Usually I ask for PDF files, right? So you publish as PDF. Now the thing is, we'll take a little bit of time. We're plotting a figure, there's no figure. It will create a PDF file. So I gave it a name, right? So on top, so do you see that that becomes the title of your document? Then my name, And then if there were section, it will create a table of content. I didn't create sections that doesn't have table of content. If I had different sections, it will have table of content at the beginning, and then every section will come right after that. So you will save this as PDF and submit. All right. You always also have to submit your M file. We usually check the published file. If we can follow and there is a result, everything is explained, that's good enough. If not, then we go and check the M file. If there was something that was stuck, sometimes we also just randomly run someone's M file. Just make sure it actually works and it's not print of someone else's work. All right. So homework number 2, you'll see it will be released on Wednesday, but you'll see that one of the questions you have to use MATLAB and you're being asked to submit M file and publish file. So M file is this one. So whatever name, maybe homework 2 question 4.m, right? And then the published file of that you have to have both of them for that question to be graded. Yes. No, don't zip, because then he has to actually download and open it. But if it was separate, you can submit many files, right? If you do that, he can just go through them and grade. Otherwise, extra work for Brad, and I know he doesn't like it. It's just not fun. Zip, unzip, and extra process. So does this part make sense? So when you are writing your code for today's block reduction, follow creating section, subsection, give it a title, put comment. All right, I'm gonna go walk around and see your style. All right, if you have the lecture open, the PDF, the MATLAB lecture, we basically covered only first page 2. So on page 3, you'll see that how to create a transfer function. So I'm going to go over here. So call your first transfer. I want you to do that. Call your first transfer function G1, right? Your second transfer function G2. Your G1 is 10 over s squared plus 2s plus 5. And your G2 is 1 over s plus 1. So 1 over s plus 1 is G2, 10 over s squared plus 2s plus, what is 10? 5. It's fine, you can cheat and use my code up there. We talked about to convert these two to a transfer function, you use TF of your numerator over and then comma denominator, right? I want everyone to type those 4 lines in your M file, in your script. If you don't have a computer, go sit next to someone that has and see what they're doing. How can Oh, remember what was the file? I'm gonna do something useful, hopefully. So I can follow the lecture slide and the code at the same time. Yes, that's gonna work for sure. There. Does it? No, doesn't like that. Okay. Here, basically, you're on this page. That's what you're trying to do. Create G1 and G2, and then I want you to add them together. So in what scenario you will add 2 transfer functions? Let's say you have a block diagram. One is G1, one is G2. How do you add them together? If they are parallel, right? Okay. So write a line that says this 1 plus this 2, then add another line and multiply them. Give it a name. From this 3, for example. Don't forget, you have to give it a name, right? For example, your section is first exam microtransfer function. Because we're gonna build on this. So what you're doing is you are creating the transfer function using TF transfer function, and you're creating an object called sys. You're gonna use this object later and apply some other function, but you already created this object. So did you also create G1 multiply G2? In what case we multiply them? In series, right? Print your result for addition and multiplication. So to print, you can either say sys, or you just don't put the semicolon, so prints. So you're gonna run this. So now we said that for addition is when we have parallel blocks, and multiplications when we have series, right? So we could also use those commands directly. So we are going to use MATLAB to reduce our block diagram. So every time you want to multiply because they're in series, you can use the command series. If they are in parallel form, you can use parallel. But you can see that here you have to, when you're naming your transfer functions, so G1, G2, system 1, system 2, make sure that you don't confuse them, because otherwise you're mixing two different things. Hear what I mean? So this is your G1, G2, parallel, your system 1, which is you called G1, is I called system 1, parallel of system 1, system 2. On this side, you're gonna have vector. This vector is an object, right? It knows there is a numerator and denominator. So when saves as numerator denominator, takes a TF because it was a transfer function. You can always use that system to get the numerator denominator out of it if you needed to. All right. Same thing for series. Now type parallel, type this one, sys parallel, sys1 and sys2, and see if you get the same result as when you added them. It's good if you type it now because you're going to actually do a reduction so you can copy paste. So type now both of these. So whatever you called your G1, G2 or sys1, sys2, you're going to follow here. If you're done with that, here, complete this is this. So all you have to do is change your numerator denominator, right? And then combine these two blocks. Again, we are going to use all of this for your block reduction. You can give it a name because if you do that, it won't reassign it, right? Right now, you're not doing anything. It's just have those commands and you can do it now. But once you get to actually review, you have to be careful that you have to follow a naming convention for yourself. So I usually have like P for total or F for final, F1, F2, F3. So come up with your own. Yeah, I will show you at the end of this one how to do that. We are going to use the transfer function that you'll find, a combination of these two, to go to our next step. Well, I lied. Did I lie? Probably a little. Yeah, I'm going to show you something else too before that. So you should have written something like this that has a numerator, denominator, your system for the first one, same for the second one here. Let's look at system one. So in the numerator, this is our system one. One, because s to the power of 0 is the first member of that sentence, right? Then for the denominator, so s squared plus s plus s to the power of 0, right? So 500 s to the power of 2 plus 0 multiply s to the power of 1 plus 0 times s to the power of 0. So every time you have this, think of it as polynomial. If some of those power were missing, then their coefficient is 0. You can't miss it. You cannot put it because then MATLAB would reduce. So this means that there's going to be a squared root in your polynomial sentence. All right, this is important. Now, once you have this, these two are in series. You can say series. So I expect you to use series and parallel instead of add and multiplication. Okay. Now, what if we have feedback? Let me put this to 100. So if you have a feedback, your transfer function, your system on the left would be feedback system one in the top line, in the direct path. Then second system, which is the system on the feedback. This is important where you put them. And then you have to decide about the sign. If this was a negative feedback, which usually is, this is -1. If it was a positive feedback, this is going to be +1. The default is -1, meaning if you didn't put this anything, you wrote feedback system 1, system 2, parentheses closed, it will assume it's a negative feedback loop, right? So if you had to reduce blocks using feedback, then this is the command you'll use. Now, if you have something like this, you have a unity feedback. You have two blocks, right? A controller, let's say your process. You can combine these two with series, and then you have to get the feedback. Now, what do we put for the feedback? So the one on the straight line is C times G. What should we put for the second system in our command? You put 1. Remember, this is the same signal, so we can say a value of 1. So feedback sys, but it has to be a vector, right? We can't just say 1. So system 1 and system 2, there are two transfer functions, right? So this is how you would write the unity feedback if you are reducing that. This is a simple example. The same transfer function you had before in series and then in feedback, this becomes your final transfer function. If you want to test it, you can perform this by hand and see they are the same. Now, these are the same. Okay. So let's say you have a transfer function for this, and to find what are the pole and 0 values, you can use pole and 0 command. So P for pole or whatever name you gave to it, it doesn't matter. P for pole is pole. This has to be pole, parenthesis this time, whatever system you want, the transfer function. So you remember sys was your transfer function object. Same for 0 is not zeros, is 0. Zeros, it will create a matrices of 0, vector of 0 for you. So if this is our transfer function, our poles are here -1, -1, and 0 is -10. So if you reduce a big block to a transfer function, closed loop transfer function, then you apply pole and 0 command, it will tell you the system pole and 0. And you know this is very valuable because you can look at the pole and say if the system is stable or not stable. All right, and we can design a controller for that. So, Another way, you can also plot the map of pole and zero. PZ map of your system. The system is your transfer function object. And then you can put it in, so the output would be a vector of pole and zeros that you can call pole zero from there. It will plot this for you. Zeros are circle, poles are crosses. It doesn't write pole zero for you. It just shows the whole map. So for example, for assignment, I asked you for pole zero map. So you will have to have this plot. Make sure all the axes are renamed. If it wasn't, if you change something in the default, make sure that those defaults are back to normal. But usually it will tell you the numbers, imaginary axis and real axis. Now, do this assignment. I don't want you to look at the solution. The solution is there. I just want you to type all of this. Since you have all the command, all you have to is copy paste, right? So first, create all the transfer functions. Then look how would you start writing those commands. Does that make sense? All right, get on with it. Oh, you don't have. You're working with them? Okay. Are you able? Yeah, once you have one Is there anything that you can directly get rid of or reduce? You remember that to reduce, you have to use series or parallel, right? You see any of those? If not, then you have to start moving the takeoff points or the sum points, right? Yeah, so yeah, yes, that's why we call it object. Then we yeah. Okay, that's good. They're actually but don't do this. Yeah. Well, you done? numerator, denominator, and then trying to create the object, transfer function object. You want to use TF on purpose, so every time you print, it would literally type numerator dash 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 denominator. It would be a transfer function object. We don't want to write 1 divided by. You're not doing this. You done? Okay. Actually, the only one that I was going to give you a compliment. Get back to what you were. You actually have to have a piece of paper and try to, when you're moving the node, right? What happens to it? You're moving the takeoff point. Remember, you have to divide by transfer function. It's good to draw those. And then, but the writing part of it is your MATLAB, the thinking part is still good. And please don't do that. Yeah, I forget it.
Yeah. But then you can
For class assignments,
yeah, so then
so I'm basically looking for the human thinking part of this. Right? A lot of it.
yeah. But then
Yes, that's the next step. Step 1, create all the transfer functions. Step 2, think about how would you solve it. Step 3 is start typing those. Step 2 is the part that takes time. Done? What step are you? Step 1, creating all.
yes, yeah, it would be,
Yeah.
so it would be, oh, no, yeah, maybe just
Go to MATLAB 1. Yeah. Go to MATLAB 9.
Whatever you
help there. Yeah, don't look at the solution. The big part is the critical thinking part, which is a step 2, and I want you to do it. So it's just numerator. Remember for the feedback, so if it's just a vector of one number, it's just a constant number. Yeah, so it's gain. Gains are constant numbers and can multiply.
because so if you would get and that you like to
You can work together for the critical thinking part. That's why you can say, for example,
No, I did it earlier. Otherwise, I don't know what.
You can do that, but you could also move aside, so then you'll have to go back, you have to use the other two back. You follow what it is? Thank you. Let's see. I can use this guy. Nine. Rotate. Yeah, I can do that. Red. Hopefully I don't blind anymore. I'm gonna use green. So if I move this one here, right? Divided by G, then these two are in series, right? Then that one is in feedback, and that one is in series, that one is in feedback, that one is in series, that one is in feedback. So I only needed to move one, take off one. What you did is correct too, but you moved 2 times everything. So the key was, I think we did, this is actually, I think is your homework, if I'm not wrong. Is it? I think this is your homework. All right, I'm gonna show you the steps to this. So we can go to the next example. All right, so the key here, so first step is to, everybody listening to me? The first step is to write down all the transfer function, right? So here, for H2 and H3, you could just put equal bracket to close. If you remember for how we did the unity feedback, that one number is like a gain. So any gain is a transfer function because you don't have S here. So you don't have to introduce it as a transfer function object. So for those two, when you're writing, you could just write bracket to bracket close, bracket one, close bracket. But for the rest of it, the key here was just the solving part of it, basically. How can I annotate again? Annotate. If you move this one here, now these two are in series, then this loop is in parallel, then sorry, feedback, then these two are in series, then this is in feedback, then this is in series, then this is in feedback. So you basically have series, feedback, series, feedback, series, feedback, right? You just have to bring the last system that you used and it would have solved. So once you do that, you would get something. Ooh, that is fine. You would get something like this big transfer function. So this is called closed loop transfer function. Now, before we say we call it the transfer function, you got it right? So the next step, you're not done yet. You have to use min real your system. This will cancel. If you have the same common zero and pole and the numerator denominator, it will cancel those out for you. This is called pole zero cancellation. That means that if you have a pole and zero on top of each other, they basically cancel each other's behavior. If it is your system, you can do it. If it was your controller, you cannot do it because sometimes we put a zero or pole on purpose on existing polar zero to cancel the effect. All right, this was part of system. So you want to use min real your sys at the last as the last step to get rid of anything that is in common factors. Now this becomes your final, like this becomes your final transfer function. You see that you have one s, like power of s less here, and these values are also different. All right, so this is always your last step. Now, I want you to do this practice example at home. It's due tonight. Again, this is an optional assignment. Use what you have, convert this, and post. Optional is not graded, but I'll look at it. This is part of your homework too. Yeah. So you'll see this one in your homework too. Don't forget, you have to do the min real for this one as well. I want you to find pole zero map of this. So for pole zero map, you have to do min real to get rid of the common values. Make sense? So do this one if you want tonight by 11:59 p.m. If you didn't, it's fine by me. Yes. Oh, first one is 2. So if you have, do you see here 4? That's a good example. So I'm going to call this G1. When I'm writing, I say G1 is 4. So this is a gain. So when your transfer function is just a number, think of it. This is 4/1, right? So there is no S, there's no zero, there's no pole, no zero on this. So this is just a gain. When you have a gain, you can just write that. If you wrote numerator 4, denominator 1, TF4, like numerator, it will be correct. It's just extra lines, right? You could do that. That's not wrong, but it's a good habit. If you have gain, directly just use the value. All right. So this is for tonight. If you want to practice, you be ready for your homework. Go ahead, do it. If not, there's a submission, but it's optional. All right, for tonight is optional. All right. So what happened here? Let me make sure that there is nothing else on MATLAB. So I talked about pole zero can. Okay, so MATLAB part 1 done. I'm gonna close this share because Zoom is weird. I can't close this one. Now, if you are here, go to modules, and I want you to take your class participation. You're switching gear to state space. I just want to check your knowledge on the state space. I'm going to pause this. Give you Right now, you're doing your class participation. Mhm. Okay. Also, something, but you can still don't submit your tax. That's fine. I assigned office hours. Tuesday and Wednesday. There weren't many of you that asked for office hours, so for now, I have 2 office hours, Red has 2 office hours. If you need it, you need either of us, and you cannot make it to those hours, send me an email, I'll use you separately for Zoom or in person, okay? I don't want you to think we couldn't make the office hours, so, oh, well, I'm gonna not do this time, right? I am there. I'm on campus every day. Also, we work on this on Wednesday, so don't worry about it. I'll move it to Wednesday. Okay. 5 minutes. If someone that's sitting next to you is doing the quiz, maybe sit 5 more minutes and give them time. Otherwise, you can leave.